Hello and welcome to our podcast about artificial intelligence. Today we'll be discussing how AI is changing the world around us.
It really is moving fast, isn't it?
Absolutely. I mean, it feels like it's not just some far-off future thing anymore. We're seeing these predictions. Microsoft's CTO, Kevin Scott, he thinks AI could write, 95% of code?
Within 5 years, yeah. That's
Yeah.
the prediction. It's huge.
It really is. And obviously, with a massive shift like that, especially in software development, you're going to see new challenges pop up, cybersecurity challenges.
Definitely. And that's exactly what we're going to dive into today.
Right. We're looking at this newly identified threat, something researchers are calling Slopsquatting, linked directly to AI-generated code.
That's the one. So yeah, AI can definitely code. That's pretty clear now. It's getting better constantly.
Mm-hmm.
But what we're focusing on here is maybe more subtle. It's
Oh.
kind of hidden vulnerability, stemming from how the AI actually generates that code.
And how that might weaken the whole software supply chain.
Exactly. So our goal today really is to unpack this slop squatting idea, figure out the nuts and bolts of how it works, and crucially, what you can actually do to stay protected.
And we're drawing on some pretty solid research for this.
Yeah, findings from Kaspersky. They've actually examined a whole load of code samples generated by different large language models, the LLMs.
Okay, great. So let's get into it. AI assistants. They're becoming almost standard toolkit for developers now, aren't they?
So for sure. Indispensable for many.
They can, whip up code snippets, finish functions, sometimes generate whole chunks of code from just basic instructions.
Speeds things up incredibly. Boost efficiency. That's the promise.
But there's always a but. This reliance seems to have opened up a new weak spot, and that brings us back to slop squatting. So lay it out for us. What is it in simple terms?
Okay, so at its core, slop squatting is a software supply chain vulnerability.
Right.
Okay.
Right.
It happens because AI systems, when they're generating code, sometimes they just hallucinate
Yeah.
or invent names for software dependencies.
Dependencies meaning the external libraries the code needs.
Exactly, the building blocks. So imagine the AI confidently referencing some tool, some library that just doesn't exist. It's made up.
Uh-oh.
And here's the kicker. This is where it gets really concerning. Attackers can spot these phantom names.
The made-up ones.
Yeah. And they can then go and create malicious software packages using those exact names and publish them to public repositories like NPM or PyPI.
Wait, hang on. So the AI basically invents a plausible-sounding library name.
Uh-huh.
An attacker sees this, creates a fake malicious library with that exact name,
You got it.
and then a developer, trusting the AI's code, might accidentally install the malicious version.
Precisely. The AI is almost unintentionally providing attackers with targets, phantom targets that they can then make real and malicious.
Wow, that sounds... Yeah, sneaky is one word for it, like the AI assistant turning on you. Do we have solid proof this is a real threat, not just theoretical?
We do. That Kaspersky research provides some really compelling evidence. It wasn't just guesswork.
Right.
They analyzed a massive data set. We're talking 576,000 code samples.
500,000, that's significant.
Huge sample size.
Hmm.
Across both Python and JavaScript, generated by 16 popular LLMs. And what they found was, well, a surprisingly high rate of these invented dependencies.
Okay, so what did they find? Were some AIs worse than others at these hallucinations, these phantom packages?
Yeah, there was a definite range, a pretty significant spectrum, actually.
Okay.
The, let's say, more advanced models, like GPT-4 and GPT-4 Turbo, they actually did pretty well. Their rates were under 5%.
Which is still not zero, but okay.
Exactly. Still a risk, but lower.
Yeah.
However, some other models were much higher. The DeepSeek models, for example, they were over 15%.
15.
Yep, and Codellama 7b was even higher, over 25%.
A quarter of the time it's making up dependencies. Wow.
It shows that even the cutting-edge stuff isn't immune, right?
Mm-hmm.
And the specific model you're using really matters here.
That's a key point for anyone just grabbing the nearest AI assistant. Did the researchers look into, like, tweaking the AI? Could they stop it doing this?
They did. They played around with the parameters, the things that control how creative or random the output is, like temperature, top values.
Right.
But even fiddling with those, they couldn't completely eliminate the problem. The rate stayed high enough that you just couldn't reliably trust the AI not to invent things.
So you can't just tune it out of the system.
Doesn't seem like it, no. And what's also kind of interesting, they found differences between programming languages. JavaScript code tended to have more phantom dependencies, about 21% compared to 16% for Python.
Huh. Any idea why?
Not definitively, but maybe something about the JavaScript ecosystem, how packages are structured or named. Also, they noted that newer technologies seem to trigger about 10% more of these phantom dependencies.
So using cutting-edge frameworks might actually increase this specific risk slightly?
Potentially, yeah.
Mm.
But the really worrying thing, I think, was the consistency.
What do you mean?
Well, they found that 43%, nearly half of the hallucinated package names, weren't just random one-offs, they kept reappearing.
The same fake names again and again.
Across multiple attempts, yes. So the AI isn't just making random errors, it's developing predictable bad habits.
And predictability is exactly what an attacker wants.
Exactly. If an AI consistently suggests a cool data parser plus,
Hmm.
and that doesn't exist, an attacker knows that's a name developers might encounter repeatedly from that AI. It gives them a stable target to create and upload their malicious version to.
Yeah, that's much scarier than random errors. It's like leaving the same vulnerability open time after time. And these names, they sounded believable.
They did. They weren't just nonsense strings. The research broke it down. About 13% look like typos of real packages. Request instead of request.
Okay, classic typo stuff.
Another 9% borrowed names from packages that exist, but in a different programming language.
Yeah.
Like using a Python library name in JavaScript code.
Ah, okay. Still confusing.
But the biggest group, 38%, use names that just sounded, well, logically plausible. Names that fit the context of the code, even though the package itself was pure fiction.
So names like user auth helper or something.
Exactly like that. Sounds perfectly reasonable, but doesn't actually exist. Until an attacker makes it exist, that is.
Right. Okay, so let's connect the dots. How does the actual slop squatting attack work then? You mentioned it's different from typo squatting.
Yeah, that's a really important distinction. Typo squatting, the traditional kind, relies on us, the human developers, making a typo when we install a package. We type it wrong.
Right, fat fingers.
Exactly. Slop squatting, though, it targets the AI's errors. Specifically, those repeated errors we just talked about.
So the attack flow is different.
Completely. Attackers can actually run these AI models themselves, generate lots of code, and identify which non-existent package names the AI tends to hallucinate frequently.
They find the AI's bad habits.
Precisely. Then they proactively go and publish malicious libraries using those specific, frequently hallucinated names in places like NPM or PyPI. They're setting traps based on the AI's known mistakes.
Instead of waiting for a human typo, they're exploiting the AI's predictable fiction.
That's a good way to put it. And you mentioned earlier something about vibe coding. How does that fit in?
Yeah, I read about that term. It's like giving the AI high-level instructions and just kind of trusting the output, maybe with minimal code review, sort of coding by feel or vibe.
Exactly. And you can see how dangerous that becomes here, right?
Oh, yeah.
If you're doing that, and the AI spits out code, including one of these hallucinated dependencies.
And you or your automated build system just blindly run npm install or pip install on everything listed.
Boom. You've just pulled in that malicious slop-squatted library without even realizing it.
Yeah.
Because you trusted the AI implicitly.
And the potential damage then could be, well, anything the attacker put in that malicious package.
Absolutely anything. Malware, ransomware, code to steal data or credentials, maybe a backdoor for later access. It compromises your entire software project.
And potentially affects anyone who uses that software downstream.
For sure. It's a classic supply chain attack vector. It maps directly onto the INI AT&T framework T1195.001 compromising software components. It's a known tactic, but slop squatting is a new way to achieve it.
And given the scale, you hear about malicious packages being found all the time.
Constantly. The Kaspersky report mentioned nearly 20,000 malicious libraries discovered in open source repos just in the past year.
The 20,000.
Yeah. So, threat actors are actively looking for ways into the supply chain. Slop squatting just gives them a brand new AI-powered technique to exploit.
This is definitely concerning. So, okay, the crucial part. What
Yeah.
can we actually do about it? What did Kaspersky recommend? How do we defend against this?
Okay, so they laid out 5 essential measures, practical steps.
Let's hear them.
First, implement automated source code scanning and static security testing. ASTI tools.
Right. Scan the code automatically.
Yeah, integrate it right into your development pipeline. These tools can help verify all the dependencies being pulled in, flag anything suspicious or unexpected. They can also catch other AI slip-ups, like accidentally embedding secret keys or tokens in the code.
Okay, so automated checks as a first line of defense. Makes sense. What's number 2?
Second, incorporate additional AI validation cycles. Basically, get the AI to check its own homework.
How does that work?
You can use AI models, maybe even the same one or a different one, to review the generated code, specifically looking for errors, and crucially, to check if the reference packages actually exist and are legitimate.
Did the research show if that actually helps?
It did, actually. They tested this with DeepSeek and Codalama. Running these self-checks significantly reduced the hallucination rates down to 2.4% and 9.3%.
That's a big drop, but still not zero.
Exactly. Still way too high to rely on only AI self-correction. It helps, but it's not a silver bullet. Human oversight is still key.
Which probably leads into the next point.
You guessed it. Third recommendation, don't let AI assistants code your most critical security-sensitive components.
Keep the AI away from the crown jewels.
Pretty much. And enforce formal code reviews by humans. Importantly, these reviews need specific checklists tailored for spotting potential issues in AI-generated code, including these dependency checks.
So specialized human review on top of the automated checks. Okay.
Fourth, create and enforce restricted lists of trusted dependencies. Approved lists.
Like an allow list for libraries.
Exactly. Ideally, you limit the packages developers can use to only those available in a pre-approved internal repository or a carefully vetted list of external ones.
That really narrows the attack surface, doesn't it? Stops random packages being pulled in.
Massively. It's about controlling your ingredients, basically.
Yeah.
Using only stuff you know and trust.
Okay, that sounds very sensible. And the final recommendation.
Number 5 is training. Specifically, train your developers on the security risks unique to using AI in development.
Make them aware of things like Slopsquatting.
Precisely. Increase awareness, emphasize why vigilance is so important when dealing with AI-generated code. Make sure they understand why these other checks and balances are in place.
So awareness and education are crucial pieces of the puzzle.
Absolutely. Because as AI gets deeper and deeper into our development workflows, and these kinds of precautions become less nice to have and more absolutely essential for protecting your software.
Wow. This has been incredibly insightful, a really eye-opening look at a very new kind of threat vector born directly from AI advancements. Fascinating, but yeah, also a bit unsettling.
It really highlights that constant tension, doesn't it? We gain powerful new capabilities with AI, but we also have to be hyper aware of the new risks that come along with them. We need to adapt our security thinking just as fast as the technology evolves.
Proactive defense, not just reactive.
That's the key.
Thank you for joining us on this episode about the future of artificial intelligence. We hope you enjoyed the discussion and learned something new. See you next time.
Thanks for having me.
And maybe leave you with this thought. As AI increasingly builds the digital world around us, what other unforeseen vulnerabilities might be lurking just beneath the surface, waiting to emerge as this technology continues its rapid advance? Something to ponder.